Hey there, curious minds. Have you ever wondered how a tiny bird inspired the creation of Velcro? Or how the beak of the kingfisher bird influenced the sleek design of a bullet train? Welcome to the fascinating world of biomimicry, where nature's designs inspire incredible human innovations. Biomimicry comes from two words, bios meaning life and mimesis meaning to imitate. It's all about learning from nature's best ideas and then imitating these designs and processes to solve human problems. Imagine nature as a giant laboratory that has been experimenting for billions of years. Today, as we start exploring this interesting idea called biomimicry, let's take a closer look at something we call biological functions. For example, when we see a cool trick, biological function, that an animal or plant does to live and thrive, we think about how we can mimic or copy that trick to improve human inventions and designs. It's more than just about copying what we see. It's about understanding the principles that make these natural phenomena possible. So how do scientists and engineers use biological functions? Well, it starts with observations. By carefully studying nature, they identify a function. Next, they abstract this function into its most basic idea. Then they use what we call a function bridge to connect a natural biological idea or function to create innovative solutions or design ideas that solve some of our problems and challenges. For example, the sun, it provides light to see. Why? So that we can see what is around us. So the function of the sun, once you boil it down to its absolute basic essence, is to illuminate. And we mimic that function with the creation of artificial lights once we take that across our function bridge. In biomimicry, when we are studying the function of an organism or natural phenomenon, we call them our champions. Think of a biomimicry champion as a superhero who shows us their amazing powers, biological functions, that we can copy to make our lives better and solve problems in a creative way. Let's take a look at our first champion, the gecko. Have you ever watched a gecko effortlessly climbing up a window and wondered, how do they do that without slipping? The secret lies in the tiny hairs under their feet. But these aren't any hairs. They're super special. They are so small that they actually interact and stick without any glue to the very molecules of the wall the gecko is climbing. By studying the gecko, scientists and engineers have been inspired by these tiny climbers that they've created an amazing kind of sticky tape that works exactly like gecko feet. But it didn't stop with tape. There are new gecko-inspired adhesives changing the way doctors help us heal. Imagine bandages that stick to wet surfaces like our organs, making surgery safer and recovery quicker, all without needing stitches or staples. And there's more. Geckos are fascinating creatures that move efficiently without wasting energy. Their ability to save energy while getting from one point to another is something scientists and engineers are keen on figuring out. Understanding this function could be used in all sorts of things, from energy-saving electric cars and trains to energy-efficient buildings. Today we learned from our champion, the gecko, about two of its biological functions: their ability to temporarily attach themselves to walls and their ability to efficiently use energy to get from one place to another. Let's explore another example. Have you ever heard of the bullet train in Japan? Engineers faced a big problem. The train was super fast, but also super loud, especially when it emerged from tunnels. The solution came from our champion, the kingfisher bird, and its ability to move from the air to the water without creating much noise or wake. The streamlined shape of the beak and its tip were the secrets to its amazing biological function. That influenced the redesign of the train's nose to pierce the air coming out of tunnels, as well as streamline the nose, making it more aerodynamic. The result, a faster, quieter train. And there's more. Let's take a closer look at a spider's webbing. One of the most fascinating functions of a spider's web is its combination of high tensile strength and elasticity. Tensile strength is the maximum amount of stress a material can take without breaking, while elasticity is the ability to stretch and return to its original shape. The unique natural properties of a spider's web are even better than those of steel and Kevlar. Another interesting aspect of the spider's web is its relationship with ultraviolet or UV light. Many types of spider's webs have the ability to reflect UV light, which can help in attracting certain types of insects that are drawn to UV light, making their webs an even more effective trap for prey. From a biomimicry perspective, scientists and engineers are looking to mimic these characteristics in the development of stronger, lighter, more flexible, and more reflective materials for use in construction, medical devices, protective clothing, and more. Nature is full of brilliant designs waiting to be discovered. Biomimicry is not just about creating new products. It's about changing the way we think. It encourages us to respect nature, learn from it, and design solutions that are sustainable and beneficial for our planet. As we continue to face challenges like climate change and resource depletion, biomimicry offers a hopeful path forward. By looking to nature's wisdom, we can find innovative ways to live harmoniously with our environment. So the next time you see a gecko climbing up the wall, remember it's not just a cool trick. It's a tiny teacher showing us how to innovate and inspire the future. Who knew such a small creature could lead to big ideas, and who knows what amazing inventions the future holds, inspired by the incredible world around us. Thank you for joining me on this journey into the world of biomimicry. Keep observing, keep questioning, and keep innovating. Until next time, stay curious.